On page 19, we're going to continue with something called function notation. We can write function notation for any graph that is a function, so that means any graph that has a slope. The slope could be positive, it could be negative, it could be zero, it just can't be undefined. Function notation is also known as f of x notation. It's useful when we're looking at more than one function at the same time. Instead of saying, hey, what's the y coordinate when the x coordinate is 7, if I have multiple equations at the same time, it might be confusing to determine which one I was speaking of. So the variable x is still what we're going to plug in. It's still the independent variable that I plug in. But the output, instead of saying y equals, we're going to replace it with f of x. So f is just the name of the function. X is what we're going to plug in. And on the right-hand side after the equals, this is the formula of that function. It's like what the recipe says we do to the x to make the output. So it works the same way as like y equals mx plus b. It just has a different symbol for the y. This f of x really replaces the y. Okay? An example for a typical question would be like, hey, what's f of 8 equal to? 8 is what we're going to plug in. Where are we going to plug it in? We're going to plug it in the formula for f. So we're going to take our 8 and we're going to plug it in everywhere there is an x. And then we're going to find what the output says. So consider this equation. Find f of 8. F of 8 equals the value of x, which is then again 8, take away 3. So f of 8 equals 3. What this statement means at the end, it says, well, if you plugged in an x, what you get out is a y value of 3. So it looks like an x and a y relationship like an ordered pair. So anytime you see a function notation statement, it will always tell you what we plugged in and what came out. It's an input and an output relationship. The number inside of the parentheses, that's your x, and what it equals, that's your y. So more practice in this section. There are 3 different formulas to choose from. For example A, it says evaluate h of negative 6, which means we're going to plug in negative 6 into the function name h. This is function f, this is g, this is the correct one to plug negative 6 into. So I'm going to write h of negative 6 is equal to 3 minus negative 6. Once you plug it in, you're going to evaluate what the output will be. 3 minus a negative 6 is the same thing as saying 3 plus positive 6, which makes 9. So your statement says h of negative 6 equals 9. You don't have to do this last part, but what this means is there'd be a point on this graph at negative 6, 9. Negative 6 would be your input and 9 is your output. Skip across to letter B. G of 0.5. We're going to evaluate that, so we're going to input 0.5 for the x into function g. So g of a half is equal to 4 times a half plus 12 and a half. Multiply first, then add. Half of 4 makes 2. 12 and a half plus 2 more is 14 and a half. So the last step you need to do is just rephrase your statement. G of a half equals 14.5. You don't need to rewrite it as an ordered pair. Why don't you practice the next 2, pause the video. When you unpause it, I'll give you the answers. So h of 5, we're going to plug a 5 into the formula which says h. We're going to plug it everywhere there's an x. So h of 5 is equal to 3 take away 5. Then we're going to evaluate 3 minus 5 makes negative 2. Your last statement is h of 5 equals negative 2. F of negative 24 means we're going to plug negative 24 into the x's in function f. We're going to multiply, then subtract, and that will tell us our output. Half of negative 24 makes negative 12. Negative 12 minus 5 more is negative 17. And that's it. That's where we're done with that. At the bottom, this directions say we're going to graph an equation that's written in slope intercept form. Even if it's written in function notation, we'll be able to do this. Works like point slope form, and it's similar by saying we first need to identify one point and then use the slope of the line to plot the rest of the points. So if you remember from the previous page, y equals mx plus b. The value of m was our slope, so our slope is just a 3. I don't want to see 3x on this line. The slope is the number in front of the x. I circled just the m, so I just want to circle the 3. The slope is just 3. And your y-intercept is the ordered pair, 0, 4. That's your b value. Okay? We're going to start first by plotting this point at 0, 4, starting at the origin. Let's count 4 boxes up. Place a point right there. And if you have a slope of 3, that means we're going to go up 3 and 1 to the right. Up 3, 1 to the right. And instead of connecting these points, we're going to go down and left. Plot the rest of the points until we run off the paper. Take your ID or ruler or something straight. Connect these points as best as you can and put arrows on both sides. And we're done with exercise 1. Exercise 2, if you want to pause and try it on your own, you may do so. First, identify the slope. The slope is negative 1/3. The y-intercept is positive 2. So that means 0, 2. Y-intercepts could be negative. We just haven't seen one yet. So let's plot the point 0, 2 first. So first we're going to plot this point. And if our slope is negative 1/3, it means we're going to go down 1 and 3 to the right. Down 1, 3 to the right. Down 1, 3 to the right. And then we can reverse by going up 1 and 3 to the left. Connect all of our points. And it didn't make a difference or any difference whether you had a y here or an f of x. So this function is has been graphed just the same way we graphed this one. Okay. The reason we identify the slope first and not the y-intercept is just because in a name we found the slope, we found the y-intercept. When it was point slope, we identified the point first and then used the slope to do the rest. So, I mean, these functions are named, or these equations are named based off of what they tell us. You just have to read and interpret it. I'm going to stop this video and move on to video number 3 to go to page 20. So I'll see you there.